Chapter 3, conversion of clinical measurements of numbers, time, and temperature. So as we go through this chapter, there is going to be assignments within the chapter. So as you can see here, there's a pretest. Any assignments we need you to do are going to be in Canvas. So you don't need to worry about anything in the actual chapter. However, it could be the same exact thing. So if we're going to have you do an assignment, we're going to take it from this chapter, but you don't personally need to go through and do these problems. However, the more practice that you do, the better you're going to get at these problems. So just keep that in mind. I'm just going to skip past this pretest right here. This is just checking your knowledge on the information before you begin learning it. It is important to be able to convert between time, temperature, and numerical systems when working in pharmacy. Many prescriptions include Roman numerals. Medications must be stored at the correct temperatures, and the correct amount of medication must be prepared for the correct time. Pharmacy employees use both Arabic numerals, such as 1, 5, and 10. So Arabic numerals are numbers we work with every day. And Roman numerals are the letter numbers such as I, V, and X, and we use these both to interpret physicians' orders. Arabic numerals are commonly used in daily life, but Roman numerals are still occasionally used in the medical field and in literature. We use the standard clock on a daily basis, whereas institutional pharmacy settings use military time to prevent misinterpretation of order timing. And finally, temperature is read and recorded in Fahrenheit in daily lives in the United States, with 32 degrees as the freezing point and 212 degrees as the boiling point of water. The Celsius scale is the basic unit of temperature in the metric system and is used in most other parts of the world, with 0 as the freezing point and 100 as the boiling point. The Celsius scale is used in most clinical settings. Medication orders or prescriptions are written in both Arabic and Roman numerals, depending on the prescriber's preference. So back when I started in pharmacy, when e-scribing, e-prescriptions they were around, but they weren't as prevalent as they are. We would sometimes see older doctors write in Roman numerals. I don't believe you're going to see many Roman numerals on prescriptions, except for if it's within the drug name or if they do use it for quantity. Right. So Arabic numerals such as 2 for whole numbers, 1/2 for fractional numbers with the household system, and 0.5 for decimal numbers in the metric system are used most often. Roman numerals, which date back to the ancient Roman Empire, use letters to represent numerical amounts. The following equates Arabic numerals to Roman numerals. So 1/2 in Roman numerals is SS with the line on top of it. So keep that in mind and have that in your brain forever, because you're going to see this on prescriptions. This you will see on prescriptions, even e-scribes. You just might not see the line over top of it. It means the same thing. And when we do Roman numerals, like the assignments, that's going to be a few of those. So just make sure you're paying attention to that, SS being at the end. 1 through 5 are definitely the most important to learn in pharmacy, especially because we have 1 through 5 controlled substances, which we use Roman numerals for. Then we have 10, which is X, 50, which is L, 100, which is C, 500, which is D, and 1,000, which is M. All right, so now we're to the rules for Roman numerals. So number 1, when a numeral is repeated, its value is repeated. So 2 i's is 2 and 3 x's is 30. A numeral may not be repeated more than 3 times. So 40 is XL, not XXXX. 3, VL and D are never repeated. So VV is incorrect because 10 equals X. LL is incorrect because 100 equals C. And DD is incorrect because 1000 equals M. When a smaller numeral is placed after a larger numeral, it is added to the larger numeral. So here we have DC equals 600, which is 500 plus 100, is equal to 66, which is 50 plus 10 plus 5 plus 1. When a smaller numeral is placed before a larger numeral, it is subtracted from the larger numeral. So XL equals 40, 50 minus 10, XC equals 90, 100 minus 10. Never subtract more than one numeral. VIII is 8, not IIX. VD and L are never subtracted. LC is not correct because 50 equals L. When subtracting, only use a numeral before the next two higher value numbers. Only use I before V or X, X before L or C, and C before D or M. The most commonly used Roman numerals in pharmacy are combinations of I, V, and X. Medical notations of Roman numerals are often written in lowercase with a line drawn over the numerals to prevent misinterpretation. Lowercase i's are frequently written with a value between the letter and the dot. So example 3.1, we're changing in 24 from Arabic numerals to Roman numerals. So 20 is 10 plus 10, which is XX. 4 is 5 minus 1, or IV, so subtract 1 from the 5. So 24 should be written as XX IV. Practice problems A, you can practice doing Arabic numerals to Roman numerals. Again, this is not required, just helping you with your learning process. Converting Roman numerals to Arabic numerals. So to change Roman numerals into Arabic numerals, divide the entire Roman numeral into the groups of letters that indicate a number, such as XIV, where X equals 10 and IV equals 4. So the Roman numeral XIV equals 14. So now we have an example, change XLVII to an Arabic numeral. So divide the numeral into XL and VII. XL means to subtract 10 from 50, which is the L, which equals 40. VII is 5, which is V, plus 1, I plus 1, I, or 7. When the numerals are placed together, XLVII, which is XL plus VII, equals 47. And then example 3.3, we're going to change XIX and then SS, remember that's going to be 1/2, into an Arabic numeral. So we're going to divide the Roman numeral into separate parts. X is equal to 10. IX is 10 minus 1, so that's 9. And then SS is 1/2. So if we put those together, we have 19.5. And practice problems B are just Roman numerals to Arabic numerals, which you can do for practice. Because traditional time can be misinterpreted when using AM and PM with the same numbers to indicate the time of day for medication administration, most hospitals and other healthcare facilities use the 24-hour clock, also called military or universal time. The differentiation of time is not just dependent on the initials AM or PM, but it is actually a different number from 0001 to 2400, Orders are written 24 hours a day, and all medical related caretakers must understand exactly when an order was written and when the medication or treatment is to take place. With this system, there is never any question as to when an order was written or which order supersedes another. In universal time, all time is expressed in 4-digit numbers beginning at 1 past midnight or 0001. There is no colon between hours and minutes. The time is stated in hundreds of hours, with 1 a.m. being 100 hours, 10 in the morning, 1,000. And then we say that is 1,000 hours. Noon is 1,200 hours. 1 o'clock in the afternoon is 1,300 hours. And midnight is 2,400 hours or 000. All right, so let's look at the clock here. That usually helps make more sense. All right, so at midnight, when the day starts, we could either have it as 0000 or 2,400. Okay, here is the 24-hour clock. The blue is PM hours and the red is AM hours. So you can kind of see, like here at 9 p.m., it is 2,100 hours and PM, and 900 hours in the AM. Just something to know. I know I just said this, but at midnight, the time can either be 0000 or 2,400 hours, depending on whatever, if your hospital has a preference. So some points to remember: traditional and universal time use the same numbers from 1 a.m. to 12:59 p.m. Hours from 1 p.m. through 12 a.m. are the 12-hour time plus 12. For instance, 5 p.m. would be 1,700. Minutes are written in the third and fourth positions and are not separated by a colon, such as 11:35. Minutes after midnight, 0000 and before 1 a.m. 0100 are written as 00 with the number of minutes following, such as 0010, which is 12:10 a.m. Midnight can be written as either 0000 or 2,400 hours. In this text, we're going to use 0000 for midnight. So practice problem C, converting the following 12-hour time to 24-hour times. In the United States, Fahrenheit temperature is the measurement most commonly used. In countries where the metric system is used, Celsius or centigrade temperature measurement is the most commonly used scale. In Fahrenheit, water boils at 212 degrees, and in Celsius, it boils at 100 degrees. Likewise, the freezing points are not the same. Fahrenheit is 32 degrees, and Celsius is 0. So we have the figure 3.2 is going to show us a comparison of the scales. As you can see, the Fahrenheit scale has 180 degrees between the freezing and boiling points, where the Celsius scale contains only 100 degrees. The formula for conversion between the two scales have been developed with these differences as the basis. The following conversion formulas may be used to change from one temperature scale to the other. So we have the Celsius here and the Fahrenheit here. Boiling point, body temperature, and freezing point noted here. Converting Fahrenheit temperature to Celsius temperature, we're going to use these equations. And you can either use the decimal form one or the fraction form. I will use the decimal form in the practice examples I'm going to show you. it's a lot easier for people to understand, I believe, and put in a calculator than the other one. However, if you've learned it a certain way and that works for you and you get the right answer, you go ahead and use whatever equation you want. So in the first method, we subtract 32 from the Fahrenheit temperature. So we would plug in whatever the Fahrenheit temperature is that we have that we're converting to Celsius here. And then we would divide it by 1.8. Now converting from Celsius to Fahrenheit, you can use either of these two formulas. And I, again, recommend using this one. So you would plug in the Celsius temperature here, multiply that by 1.8, and then add 32 to it. So in the first method, we multiply the Celsius temperature by 1.8 and then add 32. There is an alternative formula that they use in algebra. I'm not going to use that, but if you want to and know how to, definitely go ahead and do it. All right, so we'll go ahead and do some examples from the practice problems here. Okay, so we're gonna do we're gonna do all of these examples here. So for the first one, we are going from Fahrenheit to Celsius. So to do that, we're gonna use the formula C equals F minus 32 over 1.8. And then I'm just gonna rewrite it, plugging in my information. So we get that the answer is negative 17.22 degrees Celsius. So let's do that again with number 3. So we're going from Fahrenheit to Celsius, so we're gonna use the same formula. So we have 35, so I'm gonna write that here where the F would go. So 35 minus 32. Excuse me. And we get that that is 1.67 degrees Celsius. So one thing you want to make sure that you're doing is you're first subtracting. So if I were to go 35 minus 32 divided by 1.8 without hitting anything at all, I should get the right answer, but sometimes you don't, just depending on what you're doing. All right, for the next part, we're gonna go from Celsius to Fahrenheit, so we're gonna use the other formula. And we have 35 degrees Celsius. So I'm gonna plug that in. So first we need to take care of the multiplication. So 1.8 times 35, which is 63. And then we're gonna add 32. So that's 95 degrees Celsius. Or Fahrenheit, sorry. All right, and the last one, we have 19 degrees Celsius that we want to convert to Fahrenheit. So, what was that again? 19. So that is 66.2. If you are struggling, please reach out to your instructor. Don't let yourself get too far behind. Ask for help right away. It's very crucial in this program.